I'm going to go ahead and start with just from this sheet. Do any of you have the sheet with you today?
Yeah, I don't think we got that.
A couple weeks ago. All right. It is also up on the campus. But anyway, so let's just make sure we all know how to do this. Does anyone not remember how to do number conversions? Anyone at all? Okay, good. Just make sure you still have those, because there's totally a chance that one of the multiple choice questions could ask you to do some, and you need to know how to do that part. All right, so for integers, let's talk about this. The integer class is described here on your thing. Now, who remembers what this thing is called? That capital I integer. What we call it special. All right, what it was called was the wrapper class. And it's the wrapper because it contains a little int inside of it, but it also contains some of these other methods. For instance, the big integer constructor that takes a certain value, and it will, based on that value, get a big int value, or the little one that just returns the little int. That's basically an accessor. You also have two static variables, min value and max value. Now, how should you be using these? Anyone have an idea about how you should be using min and max? Michelle? Exactly right. Do you want to go through it, or should I go through it for this? All right. I'm going to take a seat because I've been standing all day. All right. So for this example here, and I'm actually going to go ahead and put up my font size just a little bit so it's a little more visible. All right. Is that good for everyone? All right. So searching and sorting. How many of you have already started to read from the Barron's book on that? Definitely do that over the weekend because it seems to be kind of our weak point. Let's go and just skip. Yeah, we'll do that. All right, so let's pretend for a moment that we had this thing which goes through the whole of this array. So go ahead and set all of our values. Sorry. There we go. All right, so let's have this thing, which is going to make an array of 50 random integers between 0 and 15, right? Everyone understands how I did that so far, yeah? All right, now I did that just that way I can go ahead and actually now go searching through it. So my search method here, if I'm looking for, or you know what, I'm actually going to change that to find minimum, find minimum, and maximum. If I'm trying to do that now, for that, this is where I'm going to go and set these two to integer min value and integer max value. This is where this thing comes in handy. Someone get the door? Thanks. So this is where this kind of thing comes in handy. Because you'll notice I set max and min to the opposites of what you might expect. Can anyone explain why I set max to min, for instance? Why max is now the minimum value? Exactly. And if I were to set max to the max value, we would never find anything bigger than it, because you can't have anything bigger than the maximum value. You guys remember what the maximum value is for integers? 2 to the 31st minus 1. And that's 2 to the 31st and then minus 1. So it's that, then that. By the way, for those who just came in, I am recording this to put up later. So if you want your voice edited out, I can do it. Anyways, so that means that the very first time that I find one of our variables that is, for instance, bigger than the maximum, I'm going to set max equal to that new variable. And that'll let me find my maximum, and I can also do the minimum in there. Now we had this in the problem where we had our rose bushes, right? Now for that, I have my solution, right? Actually, I think I might have it on the other computer. Yeah, these are the ones. Okay, I think I have it on the other computer, sorry. All right. So, switch over to .cam. All right, so here was, for instance, the get the average num roses method. Now, the average num roses method did not take an array of integers. It took a two-dimensional array of a custom thing called a rose bush. Now, that was one of the issues that a lot of you came into, is that, well, firstly, some of you kind of forgot how to go through a two-column array, so, 2D array, so let's go figure out how to do that real quick. It is still .length for it, but then what you're going to do is you're going to use the name of the array, and make sure you're using the name of the array. I see a lot of people doing things like writing rosebush there, .length, and the issue with that is that's the data type, that's not the array name, okay? I want you guys to keep that separate. So seeing that you had to get all of the values that were not null, you needed the 2D array checker that first gets the rows, the number of rows, not the roses in the flower, but rows is in the number of rows in the 2D array. In this example up here, there were 3 of them, which you can see, hopefully. Yeah, there were 3 of them in that example. So that would get 3. Now, doing garden at I.length, that thing gets how long that particular row is, because each row is really just another array. Are there any questions so far? So then to do that two-dimensional array plunderer, we go ahead and make one that goes through all the rows and one that goes through all the columns. You might call them I and J, or you might call them rows and columns, or R and C, whatever makes it easiest for you. You check to see if that element is null. We do this because it's a custom class. These are objects. These are not primitive variables, are they? They're not primitive data types. They're not integers. They are rose bushes. So we check them first, make sure that that one at that row, that column is not null. If it isn't, we go ahead and increment, well, in this case, we kept a track of how many rose bushes we had and what our sum was. We had said, okay, we found another rose bush. That wasn't null. And then we added our sum. Now here's an issue I saw a lot of you making. Notice, garden at ij returns a rose bush. That's not a number. .getNum roses allowed you to get the number of roses that that thing had. That was actually the number. Even though the table showed numbers, it was not actually a two-dimensional array of numbers. So does everyone know where to find that getNum roses method? Everyone know where to find it? Yeah, back in the rosebush class. This is pretty much the only time you need to actually mark up the old stuff or even read it, because that's where you would have found the average num roses method, or sorry, not the num roses. That's the wrong part. The rosebush, which is up there, to get num roses. Now, it doesn't show you how it works, but you don't care how it works. You just care that the fact that it gets you the number of rows. This thing could, I don't know, do long division. You wouldn't really care about that. Instead, you just got to make sure to get the number of roses. And then at the end, once you've gotten the sum of all of them, because you've been plus equalsing them, does everyone remember how plus equals works? Yeah, plus equals is basically the same as the saying sum equals sum plus garden at ij.getNum roses. You get all that, you get sum divided by the num, sum num, and there you go. That's the arithmetic mean. Now notice, you did have to know some algebra there. You did have to know the mean. They will do that sometimes. Sometimes they might have you learn about something new, like rose bushes, if you're not used to gardening, because computer scientists are interesting people. And that's something you'll find a lot of. Everything will be doing, you know, this is about athletes, this is about number ranges, this is about music, this is about rose bushes. It's always something just a little niche. Yes. What was it? No, so grid world. Let me go to make a quick note about that. One of our old textbooks in here does mention grid world, and myself, when I took the exam, I had to work with grid world. Grid world was discontinued as a case study after 2013. We no longer have to follow any kind of case study. Case study was basically where through like half the year you were using the same program and always working in that, and you got like this manual of all of its class stuff. And you would use that on the exam to fill out one of the FRQs. It was honestly kind of frustrating, but you know. So yeah, you actually don't have to worry about grid world. I noticed I made a mistake grading this, actually. This one should also say .get num roses. And don't forget your parentheses. Some of you have been forgetting those. Let's go into that anyways. Are there any other things you guys want me to show you on this before I just go on to the next topic here? Okay. Then the next topic, after the big integer class, where we were basically just making sure we remembered what max and min are, is actually doing something else with max and min. And that's called integer overflow. Now you probably will see at least one multiple choice question about this. Who can explain to me, for me, integer overflow? Anyone? Oh. Okay. Well, then let's do this. All right. Integer overflow. Guys, what's the biggest number we can represent in integers? 2 to the 31st minus 1. Everyone got that? Okay. All right. So I'm going to go ahead and get that value right here, the max value. And you're going to see that when I print out x, you're going to see, oops, you're going to see it print out to the 31st minus 1 right there. Now, if I add just one more onto that, well, actually, if I add just one more onto that value, integer isn't able to hold it anymore. So if I go just one more over, it overflows back into the negatives, all the way to the minimum value. In that way, if you keep going up and up and up, eventually you finally get to the negatives. And that's just due to how much space it can actually hold in the program. Right? So that's integer overflow. That's probably going to show up in a question. You guys have any questions about that? Okay. For doubles, the value is a little different, but they only ask you about integer max value here. A double is called a double because it can actually hold double the amount that integer can. Just a fun little fact for you. Let's see, be able to do modular arithmetic. You guys still remember modulus, right? And plus and minus and divide and multiply. Those are all still comfortable with you guys? Okay. All right. How do you extract the digit from a number? Anyone got that for me? How do we get the first digit of a number? Michelle? That's an interesting approach. Rose? And do what? Mod that. Good. Yeah. Modulus. I feel like you've been doing some C++ recently. Okay, just curious. Yeah, so guys, let's say I go back to this thing. What's the first digit here? 7. If I do x modulus 10, that gets me the remainder as if I divided by 10, and that would just get me the 7. Because if we do modulus by 10, we will get the first digit. So if you needed to make something that got all of the digits out of this number, I'll show you what that would look like. So for instance, if we needed to get all digits, void print all digits, take some integer x. Then what you would do is for int, what did I say? While x is not equal to 0, we're going to go ahead and system.out.print x mod 10, and then x divide by equals 10. So right here, with divide by equals, I move everything over once to the right, correct? Or I move the decimal place over by 1. Does that make sense to everyone? Shake your head if that doesn't make sense. Anyone confused in that? Okay. So the divide by 10, divide by equals 10 is going to take away, it's going to move the decimal place over by 1, and then there are no decimals in the integer, so the decimal goes away. So what this does is it gradually takes a number like that. It's going to first print out the first digit because that's modulus 10. Then it's going to divide by 10, making it that number. But then since it's an integer, we lose that part. It goes back up. It's going to mod by 10, print that, divide by 10, get it like that, get rid of it, mod by 10, print it, do that, get rid of it, it's now 0, it's done. And so that thus is able to allow us to then print that, all the digits there. Oops, public. Okay. And that right there gets me all the digits from the ones place to the trillions, I think, place of that maximum number. So that's just how you strip away the digits. You may be required to do that on the FRQs. So if you do see something in the FRQs that says get the third digit of a phone number or something like that, you think about something like this, all right? Using modulus. Modulus by 10 and divide by 10. Are there any questions or any other things you guys want to see done with this part? This is your review. I know you guys are computer scientists, so you're so shy and quiet. But I do want your input, especially if you're feeling a little lost. Little lost lambs. I want to bring you back into the flock. No, so. I'm sorry, I don't eat meat, so lambs are lovely and I don't eat them. There we go. Alright, so next up. Yeah. Well, I still eat fish, but otherwise. Yeah, pescatarian. Alright, so let's see this. This is a fun one. Alright, so given, let me get my hand out of the way so it doesn't keep refocusing. Given x equals 5, can you all see this, or do we try to zoom in more? Zoom in? Let's do it. Oh, okay. That's really great to look into. So if x equals 5, why does times by equals x plus 1 equal 30, but x equals x times x plus 1 equals 26? 1. Exactly. When I have it times equals, this is basically the same as saying equals, and I know I've always been saying it's x times it, but it's really x times the parentheses, then that stuff. So that would be x, that would be 5 times 6, or 5 times 5 plus 1. That's why. Otherwise, it's just normal order of operations. PEMDAS, you know? Anyone unfamiliar on PEMDAS? Say it now. Okay. Indeed. That's why this one comes out 5 times 5, make 25, plus 1 for 26. The normal rules of PEMDAS apply here. Just make sure you're working through that slowly and carefully. Yeah, and don't do that. Now, you know you can't just put two variables next to each other to multiply them, right? You can't do that here. You guys know that, correct? Because otherwise, what's to stop it from thinking that's the variable AB? Because variables can have multiple letters. Now, the one I see, and I don't know if they take off for it, but I get annoyed seeing this. Stop doing this. Stop doing that symbol. This is not a symbol on your keyboard, okay? This right there is not a symbol. It's not that. It's x is greater than or equal to 10, okay? Just remember that, please. I don't know if they'll take off work, but that's the actual thing, right? Okay. Any questions? All right. Escape sequences. You guys still remember what escape sequences are? We don't really see them too much. Yeah. So, in case you need to print out a backslash or a quote or a new line, these are the keys you would use. You do a backslash, backslash. Now, here's the thing about FRQs and printing. You never have to, really. Pretty much never have I seen printing on an FRQ. Some of you still do it because you're like, I got to do something. But you'll pretty much never see it on them. You will pretty much always see an array, array list, or two-dimensional array, and you're going to have to use a for loop of some kind on it. You can use while also, but generally it's something with a loop. It's something with building a class and/or interface, and it's usually both. Or it's some kind of advanced string algorithm where you're playing around with the string. Which part? These things. All right, so escape sequences, it's for when, and I'll show you right in here. It's for when you're, we'll just do all of that, commented out. All right, so it's for when you're printing something out. You might see this somewhere, and let's just say I don't have that line in there. So I put something in here like, hello, said the man. Now, here's the issue. If I'm printing that out as if it's a book, I should have quotes in there, right? But if I put quotes around hello, I get a problem, don't I? So instead, I might have to do something like backslash quote, which tells it, treat that as if it wasn't a quote, but print out a quote when you actually run it. So that way when I run it, you see, I now have these quotes down here. There are other ones also. Let's say I want to get a new line at the end of it, so that way this little caret thing isn't right there. I'd go backslash in to make a new line. That's one of the specialized little things we have there. So notice now, my caret is down here, because there's a new line at the end of this, as if I had made a print line instead of print. So that's how I get those backslashes in there. And then there's one other one. If I want to actually show a backslash, I do backslash backslash, which then allows me to backslash backslash this. There it is. Okay. Anything else about escape sequences, you guys? So those are just a few of them. Okay. Short circuiting. So, what does short circuiting mean? Let's get that. What does it mean to short circuit? Here it is. Public class other xn. Ooh, good enough. Maybe I should just start using the same method because I'm just being so wasteful with all these files. Oh well. So, short circuiting. Sorry about that. Let's say I had two variables, x equals 7, y equals 4, and then I'm doing something based on them. So I say, okay, if x is greater than 7 and y is less than 6, then I'm going to plus x by 1. Now, you guys know that x will not get plus by 1, right? You can see that? Because x is not greater than 7. Now, the important part to notice there is that, besides the fact that because of the and, we don't really care about what y is, it's the fact that the compiler also doesn't care about it. Once it checks this condition and sees that it's an and sees that this condition on the left here is not true, it will not check any more conditions. It will immediately exit the if statement. It will not check any of the others. Now, why is that important? Let's take it back to our null checking. So if we're talking about something like get roses again, and we were checking this. Let's say that we had to check to see if we'd only added in a sum if it had at least 10 rose bushes. Sorry, if it had at least 10 roses. So that would be if garden at I at j is not equal to null, and garden at I at j dot get num roses is greater than 20, right? Yes or no? Did you guys follow that? Okay. So in that case, if we had garden at I at j being null, and then we tried to dot get roses with it, what would happen to our program? Null pointer exception. If I had garden at I at j, and it was null, and I tried to dot get num roses with it, it would have a null pointer exception because that element was null. So by having an if statement in there that did, and Travis, I'm going to write in yours, is that okay? Okay. And I did and garden at I at j dot get num roses. It's greater than or equal to 20, I think I said. So with this, if this is null, this check never happens. Because this, once this occurs and it says, oh, it's null, it calls this a false statement, and since it's and one of them's false, it knows that it is not going to happen, so it stops checking at that point. And that's the important part, is because it stops checking here, and so it doesn't get to the point where it crashes the program. And that's the point of short circuiting for you guys. Does that make sense? An if statement will stop checking if it has an and the first condition is false. Questions? Okay. With you guys being so quiet, I don't know if you're getting it or you're just completely lost and scared to say something. It also mentions De Morgan's Law. You probably don't need to know that. I did a quick video for CSP. I'll go and just show you guys real quick what it is. Let's say, for instance, if not, x is greater than 7 and y is less than 4. So you guys can read this, right? If this stuff in here, the opposite of what's in here, basically. So if y was indeed greater than 7 and x and y was less than 4, then this would come out to true, but then the not would make it false. Now, De Morgan's Law makes this a little bit easier to solve because it's going to distribute out. So it basically says the opposite. If x is less than or equal to 7, or y is greater than or equal to 4, that's our new if statement, That's our new if statement. We can write either of them, but they both come out the same if you work them through. That's what De Morgan's Law says. I'll make these the exact opposite. If it's greater than or equal to, it's just less than. If it's less than, it becomes greater than or equal to. You have to include that equals to if it didn't have it before. All ands become ors, all ors become ands, and that's how not distributes out. It's basically a distributive property, but for not. Now, if that's too much to grasp, you can just still stick with this, right? Does anyone have any trouble want to go through how to solve one of these if statements at all? Is everyone good? Not just playing on the news, but paying attention? Everyone good? Okay, let's get to casting. So you saw this in our program, right? With casting, come on, scroll was bad. All right, with casting our random number. Now, does anyone remember why we have to cast math.random? Michelle. That is correct. If you look at our reference list for this one, random is a static double method. It returns a double. It returns a number in the range 0.0 through 1.0 exclusive. That's what the parentheses means. So that means it does not include 1.0. It means it's something between 0.0 and 0.99999, you know, all that. So in order to turn that into a random integer, we have to cast it to an integer. Now, if we did this, it would be all zeros, because math.random would be cast to an integer, and math.random is something between 0 and 0.9, right? So that immediately becoming an integer, well, what's the integer form of 0.9? 0. Good. Then 0 times 15 is 0. 0 multiplication identity. So instead, you have to first multiply the random number by 15 and then cast it to an integer. Now when you do something like that, you have like 0.5 times 15, which would make a 7.5. Now when you turn this into an integer, what is it? There you are, a random integer number. So that's what we would want to say for casting. And you'll use that with the random, of course. Multiply by the full range of it. Add by the lowest value. So if you wanted 6 through 10, you'd multiply by 4 and add by 6. Because it's a range of 4, and you'd plus by 6. Sure. So with that, generally when we're casting with, is that in here? Probably is. Maybe not. It is? Where? I'm sure it's in here. Probably is. It's a lot to read. Let's move on. Ah, here we are. Ah, maybe not. Oh well. It's typically showing up with interfaces and inheritance and such. You do this when maybe you've declared it as a parent class, but you initialize it as a child object. Did that make sense, what I just said? For which part? Let's see.
A student isn't necessarily guaranteed. That's what you're writing. So instead of being
If the right side is a child and the left side's a parent, it's fine. Yeah. If they're different, then that's how they have to be different. Here, I'll go ahead and open up an old lab. Where is it? Where's the cats? There they are, cat search. Alright, calico and cat. So, we have this parent class, cat, right? And we have this calico that extends it. It also implements that. So that means that when we... Oh, come on. Really? I have to... You know what? So that means that when we have our cat registry driver, we can make a new cat, but make it be a calico and name her Kit, because that's my cat's name. So I make this new cat, I declare it as a parent, but I initialize as a child. Now that's important because let's say I was using the method, let's say there's something particular to calicos, for instance, be a calico, which basically just makes it say, I'm a jerk. Because I don't know, just my cat's kind of a jerk, and I've noticed that with a lot of calico cats. So if I were to try and do be a jerk, it's going to have this problem because it says, oh, I can't find be a jerk in cat because I know C is a cat because be a jerk is only in the calico. But if I wrap it in parentheses and cast it as a calico, which is fine because it actually has all the properties of a calico. Let's see. Oh, yeah. And I wrap all of it. Be a jerk in calico. Why is be a jerk? Am I in there? Oh, I said be a calico. That's why. I got worried. then I'll be able to actually find it. I'm going to hit run, and you'll see it say, I'm a jerk. So that's when I would cast with a class. When I declared it differently than I initialized it, and then in order to pretend that it's actually one of those, I have to cast it. You'll see this also when you pass it to another method. Let's say there was some method called petCalico, and I give it C, and it's like, okay, but hang on, C is a cat, not really a calico. I need to know it's a calico. You go, okay. Then I'll tell you it's a calico. And that's where you cast it like that. So that's when you would do casting with a class. So in that case, so like if Kit was a calico, and then I had another cat for silver tabby or something, and they both had be a calico method. In that case, it would be whatever I cast it as. If cat also had one of them, then yeah, it would be fine. It would go ahead and call that method. It would call the child's method first, but it would be able to call that method. But since it's not in the cat class, I do have to cast it. So that way it processes it as a calico. Does that make sense? Questions on that? Okay. It's rare that you have to do that in the FRQs. It's mostly for multiple choice. Yeah, actually, a few of these cats here, Callie, Kit, and did I not have Michelle in here? Oh, that's weird. Michelle is another one of the cats I grew up with. Anyways, fun facts about me. Strings. All your string methods that you'll probably need are there, but you should probably refresh on how to use them. So, for instance, length with parentheses, no parentheses for array, size for ArrayList, but with parentheses for string, for length, just gets the length of it. Now, even though our indices start at 0, length is the total count starting from 1. There are 4 elements. The indices would be 0, 1, 2, 3, but the length would still be 4. Those? Technically, you don't need to write a constructor, no. The FRQs will almost always ask you to write one, but like in general, you don't need to have one written because the empty constructor always exists for any class you make. Mm-hmm. Yeah. There's always a constructor made for you automatically. And then when you make a constructor, that old constructor goes away. You can no longer use it. That's okay, it's useless anymore. Alright, so next, substring. You can either have one integer, in which it does it from there to the end, from to length. But if you put 2 of them in there, it's going to do from the first index to the second index, but not including that one. So that's when generally you get something like I. If you're searching the characters of something, it's I through I plus 1. That gets only this first character right here. Okay? Did that make sense? Yeah. So when you have 2 integers in there, it's only going to get from the first one to almost the second one. So if they're 1 apart, it only gets the first. If they're 2 apart, it'll get the first and the one that comes right after it. It'll not include whatever you have there. If you want to get everything from the end and want to use 2 things for it, you do it from I, or from some number, to the length of it. And that would not include that very last index. So whatever you have here will not be included. It'll be included from here to almost there. And that's why it says returns the substring beginning at from and ending at 2 minus 1. Got it? Okay, cool. So that's useful for you. indexOf is another great one for that. Like when we had our aligning our words, which I know you guys love. Number 3 was the worst one, but 1 was, huh? Number 3? Yeah, we'll go over part A of number 3. Yeah, number 3 was the one you didn't get probably for most of you. That was a tough one. Yeah, so with this one, for instance, A lot of you use either compareTo or indexOf, either are fine. compareTo, if you compare two strings, including in the substring to get that single character. If compareTo came out to 0, then they were equal to each other. If compareTo did not, then it was either negative or positive, depending on whether or not which letter came first. It would just be compareTo. Yeah, oh, from the reading? Yeah. They might show you some stuff that's similar to comparable though on the FRQ, so it's nice to be familiar with it. As you can see here, the compareTo method will return less than negative if the letter on the left comes before it. Positive if it comes after. Equal if they're the same. indexOf looks for it. If it doesn't find it, it returns a -1 because that's like an index that couldn't exist. So those are the string methods you'd want to know. The indexOf, the compareTo, and our substrings. Now, any questions? Okay, also, don't forget dot equals. That's what you use for strings and such, okay? Equals equals has a chance to fail. Dot equals will always succeed. Contrast this is a different. Okay. This late binding. Late binding. Okay. What that has to do with is what's called dynamic programming. That is not something that is covered in this course. Dynamic programming is where some part of your program has not been written before it's run. That's just what that is. It's things like memoization, not memorization, but memoization. Because it'll finish writing itself when it starts up. That's dynamic programming. Look into prime number sieves or sieve of Erasmus. We don't really have dynamic in here, though it's an interesting concept. Overloaded methods is where you have two methods with the same name but different parameters, so that when it's called, it knows which one to select because of the parameters. You have this in Java, C++. You do not have it in languages like Python, because Python can return. Well, okay, you do have that part, but you don't have different return types, because there's no return types in Python. I think. You know, I'm going to have to recheck that stuff on Python. I'm not that great at Python. Overwriting. So overwriting is where, let's say cat. Okay, meow. Meow is something in cat, okay? I can make a calico meow slightly differently by going into calico, adding in the meow method, overriding it. I don't technically need the override keyword, but I can override it so it exists here and there. I can change how the calico meows, and then go ahead and do that. And it'll go meow meow. Now notice, even though that's in both of them, because it is a calico, it will default to that one. If meow was not in here, then I would need to cast it. Once it is in there, it'll compile, and then when it runs, it does this one instead, that is in the calico class. So that might be a little tough to remember, but here it is. It'll compile if it's either present in both the parent and the child, or you cast it, and it will run the child class method. So this is overriding. It exists in the parent and the child, the same name, but different implementation. Very minor difference here, but with different implementation, right? Let me check my open broadcast to make sure we're not going too high. All right, about 45 minutes. We've been going quite a while. Any questions on overriding or overloading?
default method.
Default methods? As in the methods that are just default in?
Like, is it just like a regular string compared to a lot?
Yeah.
Okay.
Yeah. Anything else you guys want to see with method overriding or overloading? Okay. In C++, you also get operator overloading, where you can decide how plus, minus, and times will work. All right, Juan, have a good one.
What's like the integer wrapper?
So with that, since an array list has to have objects, we use the wrapper class, like big I integer, or big D double, or big B Boolean. Those wrapper classes, they have, you know, an int or a double or a Boolean value inside them, but they also have methods that go with it to access it and to process it. So,
Why are they different?
why are they different? Just because things like ArrayLists need an object. So we have an object, you know, a capital letter thing rather than primitive data type, but it still has all the functionality of a primitive data type with a little extra, like carrying along some values like min and max, and things that relate to just working with that one little variable. So the wrapper class is basically just one of the primitive data types, the little extra on it. Turn it into an int value? Wait, yes, we did that today, yeah, right? Yes, it can equal an int. Big integer can equal a little int. You would not need to cast it, but it's fine to do so. Preferably, use the int value. But if you had something like, you know, integer somewhere x equals, you know, and you made it, go ahead and use the int value if you have to. But otherwise, yeah, just carry on as if normal. This right here talks about equals versus equals equals. Use dot equals for any objects, including string. String is most typically the one you're dealing with, but you might have some others. Do you have any questions on that? Do you want to know why, or are you good just kind of knowing to use it? Such a quiet bunch. Okay. I mean, I don't want to just like bore you guys. Like, you can speak. All right. How about for each loops? Do you guys remember in Albert 5 where you had that concurrent modification error on the first question? For each loops cannot modify the elements of an array list. You will not be asked about that exception, though. The concurrent modification exception does not show up on the AP exam. As in, if I had an array list, you know, integers, that's what that word says. Array, and that's, you know, just off the side here. So I have some array list there, and I go for every integer x that is in my array list, and I try to change that variable to 2, that would not be okay. It would break. You cannot use a for each loop to change values. You can access them, but you can't change them with a for each loop. It's a minor thing, but I know some of you really like the for each loop, and that's awesome. I'm glad you're good with it, but use this only to access it. For instance, when you did the thing with the garden, with the rose bushes, that was fine. That was okay. That was just fine. You can do that because you're changing some, not the element, but you're changing some other variable, right? That's okay. You can't change that variable, though, with a for each loop. There are some special reasons for it, that X is a thing called an iterator, and that's all. Questions? Moving on, do you guys have any questions on arrays? Okay, moving on. The collections class is a class with things in it like sort. So you know how we've been learning sorting algorithms? QuickSort is stored in the collections class under the method name sort. QuickSort's not one of the ones we had to learn. It's just insertion, selection, and merge sort. But QuickSort's the one the fastest. And collections.sort does that for you because it stores that one there. It is one of our standard libraries. We can just import import the collections class, and we can get access to the sort algorithm. It's things like that. The collections has a few other things that are useful for dealing with arrays and array lists that I don't exactly remember right now. You're allowed to use that. You're allowed to use pretty much anything that works on the AP exam FRQ, but just remember that isn't technically something that that teacher would have to know. More than likely what they would do is they look at that and say, I don't really know what that is. If they weren't aware of it, they would hand it to a superior. That superior, who does not grade as many things in the day, is going to get a lot more strict with your program, maybe catch something that the other person wasn't going to, and penalize you, just watch you a little more strictly. So if you want that kind of challenge, go on ahead. But, you know, that's why we usually say keep it simple. Don't be too complex. Questions? Was what? Not quite sure. We'll come back to that one at the end. Any questions on array lists or arrays? I want this to be useful for you guys, but I don't want to just sit on something that you guys already have. So tell me, yes or no, array list. Okay. Maximum, minimum. We just did that at the beginning. Do not use 0, typically. For a lot of you with the rose garden, you went ahead and set your max equal to 0, and that was fine for this one because you wouldn't have any negative values. You know, there wouldn't be like a negative rose bush. That would be kind of impossible. So that was fine. Just be careful with it because if you could have a negative number, you would have been wrong. Just keep in mind, max and min, okay? Max value, min value. And they, if you ever forget them, are on this sheet. Right up there. Okay. Any questions about 2D arrays, max, min, array lists, or arrays? Any questions about those? Okay. I hope this thing actually recorded video this time. This document camera is bad. But it seems to work with my laptop, so that's why I'm using this. Searching. Linear search. What is linear search? What's our name for it? No?
Search.
Sequential. Sequential search is something that we saw right here with our example for school, where we selection search. Where we sequentially search for the max and the min. Now, I didn't really search for it in there. Let me go and do that now. 16. I'm looking for 16. So if I found 16, I don't know, return. I do something, right? When I find it, makes sense? Yeah. So that is a sequential search. A for loop and an if statement. That's pretty much the entire thing of a sequential search. It's just going step by step, go through all of the elements, and see if I find that query. If it were a 2D array, I would have to have one big for loop going through all of them, then one smaller loop going through all of them. You know, one for the rows, one for the columns. And once I find it, I'm done. Or I do whatever I'm supposed to do with it. Now, you know that you need a search, a sequential search, when it says something like find the minimum, or find the maximum, or find this number, or find, you know, a number entered by the user. Any other cases you guys think about that maybe would require sequential search? All right. Binary search then. You guys have any questions on binary search? Yes. Yeah, but not for us. Hash table searches, tree searches, binary search tree searches. There's a whole data structure built off the binary search. It's called the binary search tree. It's pretty cool. And then there's one based off of that called the AVL tree. Yeah. No, you guys ain't ready for chopping that one down. All right. Selection, insertion, and merge. You don't have to write, but you need to be able to work through. So do you guys have any questions on what selection, insertion, or merge look like? Yes? The code for it. Okay. Let's see if I can get one of those. Yeah, so there are a bunch of ways to do it. I'll go ahead and I'll pull up this one. Think this will work? It's here. All right, let's see. So the selection sort code, for instance. You guys want selection or insertion first? Okay, so we'll look at this one. This is how it works. Selection is a find minimum algorithm inside of a swap with a swap. So what it does first is it says, okay, I'm going to start at the very beginning for j equals 0. I'm going to go through the whole array, almost, because I'm going to check the next one. And if I find, and I'm going to start to get the minimum index. So the next thing, that would be the smallest. J is going to keep going up because it's the outermost. It starts at 0. So we start at 0. So min index equals 0. Then I start with k going to the next one. So it's j equals 1. So k equals 1. So long as k is less than the length of the list. If the element at k is less than my current min index, which is 0, min index changes to k. And then I get k equals 2. If elements at 2 is less than elements at min index, whatever that might be, 0 or 1, change min index to 2. Then k equals 3. I'm going to go ahead and see if the element at k is less than the one at the min index. This is me checking for the minimum.
So, like, if there's this and then this again, or does it just keep on doing this?
It'll keep doing this until it gets to the end of the list. So now it's checked from 0 all the way to the end, looking for the minimum index. By this point, it's checked, and every single time it found something smaller than the last minimum, which is going to be the first element from the first time, it changes min index. You guys have any questions on this part of just getting that minimum index?
So this runs.
Yeah, this runs, yeah, n minus 1 times. Where n is the length of this array up here. All right. So then, by this point, exactly. If I'm thinking about this in an FRQ kind of way, I've gotten my minimum. Now I got to swap them. So I use these 3 lines here. Why do I use these 3 lines? Take a good look at it and think about how this works. Yes? You want to try it? Good.
So if you have, like, these are the 2, you have your min and you have your element at j and you have your element at that's 2 different things as of right now. The thing is, if you set elements at j, this element at min index, and elements at j, it's going to equal the same thing again twice, which is how much you want the values to swap. So you're going to have an intermediate variable that stores the original value of elements at j, and then a new variable that will change min index to j well.
Good. So with that, I have now swapped j, which is 0 on our first run through, and the minimum index So that way now, my leftmost element is a sorted array, technically, of one element in size, the smallest. Go back up to the top. J equals 1 now. Min index is equal to 1, because now we're done with that first element. We're done with that. Now we're going to go from 1. Now k becomes 2. K is less than our thing, so we check. Is elements at 2 less than elements at 1? If it is, change the min index to 2. Keep going until we've gone through the whole length of it. We now have the min index for the next element. Swap them. Now we have a sorted array of size 2, and all the rest are unsorted. So then j becomes 2, so that's the next index. K becomes the one after it. Does that make sense? And we keep going until we've sorted everything. We keep finding the minimum value, selecting it, and swapping it out with the old one. Question? The selection of the sorts get a little tougher. Now, insertion sort is the slightly more, typically it's slightly more efficient. Here's how that one goes. It's a little tougher to get. J starts at 1 because it's going to go backwards. We assume that the first element is a sorted list. Because if I have the number 5, is that sorted? Yeah, it's sorted. There are no bigger elements to the left and no smaller elements to the right. It's just a 5. Technically, that's sorted. So we skip that first element. We go through the whole list, and as we go through this pass, we get the element we're currently at, the very next element, and we say, okay, its new possible index is going to shift. Right now, both elements of j and the new possible index are in the same place. Now, keep going so long as possible index is greater than 0, and that element that we're currently at is less than the elements at my new possible index. We're checking the one before it. So if the one at 1 is smaller than the one at 0, it's going to enter the while loop, change my possible, change that one, the one before it, subtract 1 from possible index. Temp still holds the old value, but now we've moved this one up, or moved it back. What happens is, we'll go ahead and draw it. So we had 4, 2, 5. J equals 1, so J is pointing right here, yeah? Temp equals 2, right? Or equals the array at J, right? This one. Yeah, J is the index, and then T equals, the value. Elements at J, which is 2. Possible index is going to equal J, which is 1. So J equals 1. Possible index equals 1. J equals 1. Is possible index greater than 0? Yeah. And temp is less than the one before it, possible index minus 1, which would be 0, so it's this one. Is temp less than that one? Yes. So then in that case, elements at the possible index, which is here, equals the one before it. So 2 becomes 4. And we subtract 1 from possible index. We go up. Possible index is no longer greater than 0. So the elements at possible index, which is 0, now equals temp, which equals 2. Changing this 4 into a 2. We have now sorted the first two numbers in our array. 2, 4. And then the next one will be 5. Any questions about insertion sort? A little weirder. Honestly, this one is one of the ones that took me a long time to actually kind of get. All right, any questions about insertion or selection? Okay. You guys have anything you want to go over about merge sort? What is it? Yes, divide and conquer. We're going to go past my silliness there. So, here's what happens. We aren't really going to look at the code too much. Instead, we're just going to go ahead and count it out. For an array with 8 elements, what it does is it first splits them up into 2 segments, and then splits those up into 2 segments. And then if it can split those up into 2 segments, it does, which you can see there. Now they're all single elements, right? So far, that's all I've done. And then it's going to go ahead and merge them back together. So it merges these 2 back together. Now, are these out of order? First, right here, are they out of order here? Yeah. Yeah. Oh, sorry, yeah. In their individual. Together, would they be out of order as 32 and 2?
The groups of 2 are.
Yes. So that means we swap them.
Wait, so does it break it down into the individual sections, or does it stop at the smallest possible arrangement? So when I break it down into 2s.
The base case usually stops it at 1. At size of 1. You could stop it at length of 2. It'd be up to you on what algorithm you're using. I learned it at size of 1, that's why I go down to 1. Because the merge is what handles the swap. The swapping only happens with the merge, and it will swap any of them that are supposed to swap, and make 4 sorted lists. You notice this last one doesn't swap because it doesn't have to. Does that make sense so far? Okay. Next, it'll merge these 2 together. It'll go ahead and sort those. Probably with insertion sort.
So it's a bunch of groups.
Exactly. Does an insertion sort on these 2. These 2, these 2, these 2. Does a sort on these 4 and these 4. And does a sort on the full 8.
Why is that?
What happens is we end up only having to do
Like it, yes, it's less sorts, it looks like it's more than first sort.
in the end, no, it's kind of hard to explain why.
Okay.
We can count it up in that we only have 1, 2, 3 merges for 2 to the third. Questions? Okay. For that, yes. Okay. See ya. We'll hopefully have this up soon. For writing any classes, make sure to do all these things. Thank you for coming, by the way. You guys have any questions about writing classes? Wait, Laura, is that your book? Oh, okay. So we'll use, I don't remember, did I say this one?
To learn about we're typically just your main method.
Yeah.
Is it always your main method?
Yeah.
Oh, because that's the only one.
Mm-hmm. When you're writing a class, for instance, let's go ahead and start with the interface part. You'll see this in your reading, but the number range? Yeah, that's the one I expected everyone to get.
Everybody kind of failed.
It went the opposite way with some of you, where you got all of them and then not that one. Yeah, that was the first part. Yeah.
Oh, I love that.
I forget why I have minus 0.5 for him.
Got it.
Yeah, where's your one?
You do have overall.
Yeah. Oh, you know what? You didn't have a semicolon. That's what it was.
Oh, it's an interface. It's fine. Okay.
No, yeah, for the method. So
Yeah.
basically, an interface has no defined methods. It just names what methods should exist in a number. So that's all for an interface. I just got to name any methods and name it itself. I'm going to have you guys do one of those with a on our mock exam.
Can we have our stuff?
Yeah. I think I figured. Yes.
It's okay if you have that.
Okay. Yeah. So then we get to our class. It's a complete range class, which is implementing number group. So the first thing to remember about anything like that is I have to implement any methods that the number group itself made, like contains. And it's got to look the exact same, except without something. And then it does those things. In this case, I wanted you to understand that this was not an array, but a simulated. For instance, you can have an array of -3, +2, all of the whole numbers, just by having the 2 numbers on the ends. Because then whenever you want to get one of the numbers in there, you just got to use some math, use some methods, and you can get those values. You don't have to store them. When things are predictable like that, you don't have to store them.
Oh, you weren't supposed to. Wait, were you supposed to really contain method B?
Yeah, well, where's it?
Because how do you define it somewhere else? I think
There's another one where you also have to make a contains method for a different thing.
Because I was going to write it here, but then it didn't need to be there, so I was like,
Oh, yeah. It's in both places.
okay.
This
that
one-
makes so much more sense.
This one implements it, so
Okay.
yeah, it's got to
Yeah.
happen. And its constructor should initialize all of the
Variables.
IDs.
Yeah, because I did that part, but I didn't know what was up with this. So.
I gotcha. So then with contains, it goes greater equal to min, plus equal to max, return true. And then don't forget to return false.
Else return false. Or actually, do you need something, or do you
No.
just like outside the loop?
Just upside the Exactly. Because when you return true there, you wouldn't go on any further. It wouldn't change the return value. So yeah. But you do need something there, otherwise you're not returning anything. So yeah, that was this part. Question?
No.
Be very thorough. Make sure you. Yes, let me see if it's up there. I'll go ahead and leave this right up there. The next example, I'm not here to do it. Here we go. That was fast. On number 3, particularly, because number 3 was kind of impossible. All right, so for this last part,
Never any constructors.
which part, number 3?
Travel cycle. Yeah.
Yeah, that was awful. Yeah,
There were like no constructors defined. There were like like the 2 examples had different parameters, so I was wondering if it was like a different constructor for each, but it looked like they had the same stuff in both of the calls, and I was like, I don't know.
It got really weird. Now, for this one, oh yeah, I took up the 0.5 for size and size. Yeah. So with this one, this is like very classic kind of thing you have to do, Kyle. Very classic thing is using the method you just wrote.
Yeah.
So for instance, this contains is in a different class. I think it's called range. Or it's a group of them. And so the group list is an array list of number groups. That's the interface.
Wait,
Now,
how do you have an array of how do you initial?
because
how do you
you're
have an object of its interface?
because you're declaring it as interface, but initializing it as child.
Oh,
It's initialized as one of these.
as a range?
You may. Yeah.
It's initialized as a range.
Yes. Because these are each ranges. And that's why it could be initialized as a child, but declared as a parent. And then with that, my group list, I go through the group list that, get that wrong. Here I'm discovering all my little mistakes.
Gosh.
Dot get at I, you gotta include that. Dot get at I, dot contains, because contains is in that range class. Make sure to turn off the computer. You have to hold on the power button until it dies. Alright, if it dot contains, which returns Boolean, true or false, then return true. Otherwise, return false. If you made it through the whole thing without finding it, do not do that thing people do where they go, else return false. Because that would do it on the very first time it checks. This checks it null. For loop is where you're finding it. And you only say, I didn't find it, after you finish the for loop. Do not return false.
Oh, so you don't write the else statement in here, you just write things off there.
Yes.
Cool.
Because otherwise it's going to check the first one. If it's not that, it returns false.
It'll return false for the entire.
Yeah.
Okay.
Echo.